Hello students, today I'd like to discuss about a new chapter, okay, which is a new chapter that is continuity and differentiability, okay. This chapter is for the particularly theory syllabus. It is having a 20 marks for the annual examination, okay, right. How the 20 marks distribution will be there? First we need to check, concentrate on the board. The 1 marks means from the part A, 1 marks, 1 question will be there, means 1 marks it will be. 2 marks, 2 questions will be there. 2 marks, 2 questions means 2 into 2 will be 4. 3 marks, 2 questions will be there. That is 3 into 2, it is 6. Yes. 4 marks, 1 question means 6 plus 4 tagged will be there. Part E. In that, it is a tagged question. 4 marks, 1 question, that is 4 marks. And that is part D. 5 marks, 1 question will be there. That is 5. Okay. This will be 5 plus 4, 9. 9 plus 6, 15. 15 plus 4, 19 plus 1, 20. Got it? Means it is having a 20 marks in the annual examination. Okay. Then what is the meaning of continuity and differentiability? I think you already learned in the first PU part, limits and derivatives. You must require the basics of the limit concept. Okay. That I will cover in the next part. Okay. What is the meaning of continuity and differentiability in this chapter? I'd like to cover. Basically, what is a continuity differentiability? It is all about a calculus only. It is in the part of calculus. Okay. What is a calculus? Calculus is a mathematics of motion and change. Means in the inverse, there are so many changes and motion will be there. If there is a slight change or more change. But whenever it is a slight change means either motion or a change is there, means right mathematics to apply is calculus. Got the point clearly? Okay. Then Newton and Leibniz, right? The Newton is a well-known mathematician as well as a physician. Newton and Leibniz independently invented the calculus. Okay, the calculus is nothing but this is the word from the Latin, the any in the from the Roman cities. Olden days Romans, they are using count for the counting days. They are using the stones. They are used the word as a calculus. Now, the next concept is, what is a basic concept of continuity we need to discuss here. Okay, the continuity of what means, general meaning of continuity means without having a break. Means try to understand what is a continuous means. Whenever in the graph, whenever you are going to draw the graph without lifting the pen from the plane of the paper, that is called as continuous. If I am going to draw the graph and I am lifting the pen and I am again plotting the graph, then it is discontinuous. Got the point clearly? Okay. Means I'd like to take one example particularly. Concentrate. In this one, I'd like to define the graph y is equal to x. Okay. Y is equal to x means I'd like to take some basic values here. It is x, x dash, y, y dash. Okay. Fine. See here, if x is independent, if x taking the value, if x value is 0, what is the y value? X value is 0, y value will be 0. Okay. If x value is 1, x value is 1, y value is also 1. X value is 2, y value is also 2. Exactly. If x is equal to 3, y is equal to 3. Got the point? I took a positive as well as I'll take a negative. If x equal to minus 1, y is equal to minus 1. If x equal to minus 2, y is equal to minus 2. If x equal to minus 3, y is equal to minus 3. I'd like to draw the graph here. Concentrate. It is 1, 2, 3, 4. Okay. It is minus 1, minus 2, minus 3, 1, minus 1, minus 2, minus 3, minus 4. Okay. It is 1, 2, 3. Okay. See here, if x value is 0, y value is 0 here. X value is 1, y value is 1. Okay, x value is 2, y value is 2. X value is 3, y value is 3. X value is minus 1, y value is minus 1. X value is minus 2, y value is minus 2. Means whenever I am going to draw the graph, I am drawing, I will get the line means I'm drawing the graph without lifting the pen from the plane of the paper, from the plane of this board. Okay, that's why it is called as a continuous graph. There is no break or no jump will be there. That's why it is called as a y is equal to x is a continuous graph. Got the point clearly? Okay, I'll take the one more example here. I'll take the one more example, y is equal to x square. X square is a particular function, okay? We are defining the continuity of the particular function. Last part, y is equal to x is also a function. Y is equal to x square is it is a square function. Got the point clearly? Whenever x value is equal to 0, y value will be, yes, it is 0. Whenever x is equal to minus 1, if it is minus 1, what is minus 1 square? Y is equal to 1, okay? X is equal to minus 2, y is equal to minus 2 square will be 4. Got the point clearly? In the similar manner, I'd like to take it for the positive also. X is equal to 1, what is y is equal to 1, okay? X is equal to 2, what is 2 square? Y is equal to 4. Got the point clearly? X equal to 0, it will be 0, 1, 2, 3. It will be minus 1, minus 2, minus 3. Okay, now concentrate on the board. When x equal to 0, y is equal to 0. When x is equal to minus 1, y is equal to 1. Okay, this is 1, 2, 3, 4, 5. Okay, the graph will be x is equal to, whenever x is equal to minus 2, its value will be 4 here somewhere. Okay, the graph we are getting like this. Okay, x equal to 1 plus 1, it will be 1. X equal to 2, it will be, y will be 4. It will be here. Okay, now I need to draw the graph like this. It is a upward parabola graph. Got the point clearly? Whether I am drawing the graph, whether I am lifting the pen from the plane of the board, no. It is continuously I am drawing the graph. Means there is no break or no jump is there in the graph. That's why square function is a continuous function. Okay. I'll take one more example here. The next example is also about the continuity of the function. I drawn here the graph of sin x. You already know the graph of sin x in the inverse trigonometric function. Okay, I drawn the graph. Whether I am drawing the graph, whether with lifting the pen from the plane of the paper, no. Means I am not lifting the pen. Continuous graph is there. There is no discontinuity. Got the point clearly? That's why it is continuous. There is no break or no jump in the graph. Next part, what I am discussing is, till now what we discussed, y is equal to x is continuous, y is equal to x square, square function is continuous, y is equal to sin x, this is also continuous. Okay, now the next example I'd like to take is, which is discontinuous function. Now, okay, concentrate. Okay, I'd like to take the next example is about the discontinuity, y is equal to 1 by x. How we have to understand this one? Okay, concentrate on the board. If x is equal to 1, okay, x value is 1. What is x value? 1. 1 by 1 will be, y will be 1. Got it? What about x is equal to 2? X is equal to 2 means 1 by 2. What is 1 by 2? It is 0.5. Got the point clearly? Okay, if x is equal to 10, what is x equal to 10? X equal to 10 means 1 by 10. 1 by 10 means it will be 0.1. Got the point clearly? Okay. Then what about for x is equal to 0? Yes, 1 by 0, which is not defined. I can't select x is not equal to 0 in this function. X is not equal to 0. Okay. If I am going to take 0, it will become indeterminate. Okay. Now, then x is equal to minus 1. Y will be again minus 1. Why? Because 1 by minus 1 will be minus 1. When x is equal to minus 2, x equal to minus 2, 1 by 2 will be, yes, it will be 0.5. Y will be minus 0.5. Okay. When x is equal to minus 3, x equal to minus, I will take minus 10 only. It will be y is equal to minus 0.1. Got the point clearly? Okay. Then how to draw the graph here? Concentrate. X is equal to 1, x equal to 1, y is equal to 1. The graph point will be here. X is equal to 2, it will be 0.5. Okay, x equal to 10 here somewhere, means the graph will be like this. Okay, got the point clearly? Okay, whenever x is less than 1 means 0.5, 0.2, 0.3, it will be more and more and more values like this. Got the point clearly? Okay, I'll take one more negative values now. X equal to minus 1, y is equal to minus 1. Got it? Okay, x is equal to x equal to minus 2 will be minus 0.5. Here somewhere we'll get, okay, the graph will be like this. Okay, got the point clearly? Okay, the graph will be like this, but try to understand whether it is defined for the 0. No, it is not defined for 0. Why? Because at 0 it is indeterminate. Means, I think you understood at what point the given function is discontinuous. Yes, at exactly x equal to 0 the given function is discontinuous, because we are not getting the points to plot on the graph. Got the point clearly? It is discontinuous. Okay, I'll take one more example. Okay, next graph I'd like to explain is greatest integer function. You already learned this greatest integer function, or you can say it as a less than or equal to integer. Okay, got it? That is 0. What is a 0 greatest integer? 0 only. What is a 0.1 greatest integer? That is 0.1. 0.1 means less than or equal to. Less than integer is 0 only. That's why it will be like this. The graph will be at 1 means, what is the greatest integer function for the 1? Yes, greatest integer function for the 1 is 1 only. Here I'd like to draw the graph. Okay, then what is the value of 1.1, 1.2, 1.3 till 2 means, till 1.9 it will be 1 only. For exactly 2 its value will be what? Its value will be what? 2 only. Okay, got it? Then till 2.9 it will be 2 only. 2, when it will become 3, its value will become 3 in the range part. Got the point clearly? Okay, then for the 4 it will be 4. Okay, again like this. Okay, then what is for the point minus 1? Point 1. Okay, minus point 1. Minus point will be its left integer will be, yes, its left integer will be, okay, minus 1 here. That's why the graph will be like this. Okay, till minus 0.1 it will be like this. For the minus 1.5 its value will be minus 2, means the graph will be like this here. Got it? For the minus 3, yes, it is minus 3 only. But till what is minus 2.5? Minus 2.5, its value will be minus 3 only. Got it? It is a graph that you already learnt in the function chapter. Okay, means whether this graph is continuous, means whether I am drawing the graph continuously without lifting the pen from plane of the paper. Yes, try to understand. Yes, see here, from minus 3 to minus 2 I drawn like this. Again I am lifting the pen. From minus 2 to minus 1, again I am going to lifting my pen. Okay, minus 1 to 0, again I drawn. Means for every integer I am lifting the pen. Means, at what point the greatest integer function is discontinuous? Yes, exactly. Every integral point, at every integral point the function, greatest integer function, is discontinuous. Got the point clearly? It is a graphical method to understand the discontinuity or continuity of the function, whether the function is continuous or discontinuous. Got the point clearly? Okay. Okay, what is a continuity of the particular function? Okay, the continuity of the particular function, the function f of x is said to be continuous at x is equal to a. It is a particular point at x equal to a if the value of the function at x is equal to a equals the limit of the function. Okay, the function at x is equal to a equals the limit of the function at x equal to a. Limit of the function means how it will be? Limit of the function will be that limit of the function, limit of f of x as x tends to a is equal to f of a. What is the meaning of the limit? Means it says when LHL equal to RHL, when it is equal to at that point, then only we can say the continuity. A function is said to be continuous at x is equal to a whenever limit of f of x as x tends to a is equal to f of a. Got the point clearly? Is it okay? Observe the example here. Okay, I'd like to check the continuity at x is equal to 1. Why? Because the function is changing at exactly 1. That's why I need to check the continuity at x is equal to 1. Okay, I'd like to write here LHL part. Okay, what is LHL? Limit of f of x as x tends to 1 minus. 1 minus means less than 1 function I'd like to select. Limit of f of x means here I need to take x equal to 1 minus less than 1. Less than 1 means yes, exactly, x plus 2 I need to take. Okay, x must be replaced by 1. What is 1 plus 2? 1 plus 2 value will be 3. Got the point clearly? Okay, then what about the RHL part? RHL part will be limit of f of x as x tends to 1 plus. Okay, what is 1 plus? 1 plus means greater than 1. Limit of x tends to 1 plus. 1 plus means greater than 1. Which function? X minus 2 I had to take. It will be 1 minus 2. 1 minus 2 will be minus 1. Whether LHL equal to RHL? No. LHL is not equal to RHL. Limit does not exist means it is not continuous at x is equal to 1. Got the point clearly? Okay. Observe the board here about the properties of continuous functions. Means how the functions are, general functions are continuous. Concentrate. Composition of two continuous function is continuous. Composition means how it will be. It is f of g of x means in one function whenever another function is defined, then composition between two function is continuous. Means f of x is also continuous, g of x is also continuous, means composition of two continuous function is continuous function. The next one is every polynomial function is continuous. Polynomial means either monomial, either quadratic, cubic. Every polynomial function is continuous function. Okay, every rational function is continuous. Rational function means f of x divided by g of x. The numerator is also continuous function. If the denominator is also continuous function, then the ratio of two continuous function is again continuous function. That is nothing but a composition functions are continuous function. Every polynomial function is continuous. Every rational function is continuous functions. Okay, I'll provide the proof one by one here. Okay, concentrate. Here the composition of two continuous function is continuous. Composition means for the composition function we required two functions, that is limit of f of x as x tends to a is equal to f of a. This is a continuity of a function f of x at x equal to a, and I defined one more function here. G of x is a continuous function at x equal to a is equal to g of a. I'd like to define a composition of these two functions. It is f composition of x, f composition g of x. How I have to write? At the point x is equal to a, I need to define. Concentrate on the board. Limit f composition g of x as x tends to a. Now I'd like to write this one as a limit as x tends to a. How I have to write f of g of x? It will be f composition g of will be f of g of x. Got the point clearly? Okay, now the next step will be limit as x tends to a. How I have to take as x tends to a, g of x tends to g of a. That's why here x tends to a will be changed as g of x tends to g of a. I wrote. Okay, got it? It is f of g of x. Got the point clearly? Okay. After observing this one, I'd like to write the term as limit as g of x tends to g of a. The function will be changed to what? F of g of x will be changed to g of a. Got the point clearly? Okay. What is f of g of x? It is nothing but a f composition g of a. Whether I got the continuity of the function now means I started with the f of x as x tending to a will be f of a. I started with the f composition g of x as x tending to a will be f composition x is replaced by a, means the composition of two continuous function is continuous. Here the next property is every polynomial function is continuous. That is p of x, I defined a general polynomial of the nth order. Okay, I'd like to define at x is equal to, instead of taking a, I'd like to take it as a c because a is already used in the property. At x equal to c, I'd like to define, okay, concentrate on the board, limit of, instead of taking f of x, I'll take p of x because polynomial function is p of x as x tends to c. Okay, got it? Now limit as x tends to c. What is p of x? Oh, yes, we already know this one. I'd like to substitute this one. A naught a1 x plus a2 x plus a3 x so on up to an x. Got it? Then the next step will be, as x tends to c, wherever x is there, I need to replace with a c. That is a naught, a1c, a2c, a3c, plus so on up to an c here. Got the point clearly? Is there any doubt in this one? This is nothing but what it is. See, p of x is a naught, a1x, a2x. See here, a naught, a1x. Instead of x, yes, see, a2 as it is. Instead of x, c is there. It is nothing but a p of x. It is nothing but a p of c. Means what I got? Limit of p of x as x tends to c, it will be p of c. We got the values. Means every polynomial function is continuous. Okay, this one is the last property. Every rational function is continuous. Okay, here I defined rational function f of x equal to p of x divided by q of x, where q of x is not equal to 0. If it is equal to 0, it will become indeterminate. Got it? Here p of x is continuous at x equal to a, q of x is also continuous at x equal to a. That I defined here. Okay, got it? Now concentrate. I'd like to define the continuity at x is equal to a. How to define a continuity at x equal to a? Limit of f of x as x tends to a is equal to limit of x tends to a. Okay, got it? What is f of x? Can you say? F of x is nothing but p of x divided by q of x. Got it? Now, limit can be applied to numerator and denominator separately. That is, limit of p of x as x tends to a, denominator will be limit of q of x as x tends to a. Got the point clearly? Okay. Then, what is limit of f of x as x tends to a? It will be, yes, f of a. Okay. Then, what is limit of q of x as x tends to a? It is q of a. Got it? Okay. Then, p of x divided by q of x is f of x. What is p of a divided by q of a? Yes, it is nothing but f of a. Got it? What is the left part of the function? Limit f of x as x tends to a is equal to f of a. Means every rational function is continuous function. Okay, I think you understood the part. Okay, try to analyze all the part. In the next class, I'd like to solve the problems based upon continuity of the function. Okay, good day.